Okay. Okay, so this evening we are going to start our class and we start our lab journey, considering now that we are still under ODL, under movement control order, so we can't actually go to the lab to do lab face to face, so we have to do it online or ODL. And but before we proceed with that, we need to install the Labview 2014 Service Pack 1, which is the trial version. Now, the problem with this, if I'm not mistaken, is that if you just click on, sorry, if you just, hold on. Okay, so if you have downloaded the link that I've given earlier last week, you will see this one .iso. If for those who are familiar, is actually a soft copy of a CD installer. So if you double click on it, you'll see that here in your My Computer, it's sort of like mount a DVD ROM in a DVD in your My Computer. So you can see there's a CD emulation of a CD there. So if you double click, it's sort of like loading a CD into your computer. So you click Setup here, and it will guide you through this an Is Labview 2014 for education. So you just click Next, and then you have the option to join, but I suggest not, because this is just evaluation version. So chances are, even if you can't use it, they will still bombard you with all the updates and whatever newsletters from National Instrument that you may not want during your after this lah. So just untick it, click next. Okay, this, if you don't want to do anything, just leave it like this, because we are using evaluation mode, so you don't have any serial numbers. So just click next. And then this one also, just click next if you have, preferably put it somewhere in your OS partition. Like me, I have here, I have what, three partition, and all my operating software, uh, all the work software, I put it in my OS or C, so to make it easier for the computer to search, and also to launch the program much easier for it to calculate or whatever not. Just put it into C, because my C is in SSD NVMe, so it's quite fast. So loading up a program will not be an issue lah. So if you have SSD in your computer, put it into that SSD hard drive lah. Sorry, what do you call that? C or D, the partition. Yeah, sorry. And then click next. It will bring you to the installation. Before that, you have to click I accept, next, I accept, next, and then you can do this. But for me, I just untick the disable Windows startup. And then, if I'm not mistaken, after this, it will start installing. But since I've already installed the program, and I would rather to just use it, and rather than uninstall it and then reinstall it and then have to wait for what, 40-30 minutes, I would rather just keep it. And for you guys, click next, and it will guide you through the installation. And after that, it will ask you to restart your computer. You can do that, but I suggest you restart it after the class ended, so that it is, because we are in a lecture room, so might as well we finish the lecture, the lab, where I guide you through the lab, pre-lab 1A, and after that you try it on your own, because everything will be recorded and you can just review it back. So if you click next, it will guide you through the installation, and we'll start install. And yeah, I believe when I did install it on my NVMe SSD, it took me around 40 minutes or plus. So if you install on a hard disk, a mechanical hard disk, chances are it will take more than that. So I wouldn't click next here. So for you, just click next. And after that, if it asks you to restart, wait until the class ended and then restart your program for you to try the Labview. It's actually a fun program, Labview. Okay, so I click cancels because I've already installed it. As you can see here, I already installed it here. So before we proceed with that, okay, please all of you try to click next on that installation ISO, on the setup that I've mentioned earlier. Click next and then wait for it to install. And while it's installing, just look at the Google Meet for us to proceed with our Lab 1A, which does not have anything much. It's just where I click point here and there. Now, if I'm not mistaken, once you have completed the installation, it will state there the first time you run it. If I'm not mistaken, okay, let me open. Okay, so the first time after you restart your Labview, install your computer, after you restart your computer, you will see this. Once you click the Labview icon, you will see there Labview or whatever, not here, evaluation mode, and 7 days remaining. Now, if you proceed with 7 days remaining and just launch Labview, what happen is I don't think you'll be able to use Labview to finish up your mini project. So what I suggest is activate the products, but let's see, not activate the product, not activate the product, but there's a link, if I'm not mistaken, over down here where it asks you to go to create an account. I'm not, can you double check on me later when you've finished up downloading the Labview and first time running it? If I'm not mistaken, there's one link here that asks you to create a program, create an account with a national instrument. I advise you to click on that. Go to create your account. It's just a simple of. Let me double check if I still have the registration here. Hold on. Not here. Nope. Yeah. So it will bring you to this, if I'm not mistaken, this national instrument as well, where it'll ask you to create a user account. Just create it. You don't have any kind of payment for you to do. It's just your name, your location, and your contact number, if I'm not mistaken, and your email. That's it. And then it will create an account for you to do that, and then it will sync with your Labview account here, with your program, and then you'll have 45 days remaining, much like I have to right now, 44 days. So just use that because at the very least, you'll have enough sufficient time for you to finish up your mini project. Mini project duration for the 45 day, I think it should be enough for your mini project duration. Okay, so if you can't recall after this, just review this recording and then do what I've just told you lah, which is to go to National Instrument link. If I'm not mistaken, there's a link down here. Double confirm me on that. Just snapshot and share with me. I'll guide you where did I click. Okay, so before we proceed, I'll just give you some overview on using Labview. This is just what you call that. Okay, and one more thing, if you don't want to use it anymore if you've completed all the installation, you can just press eject. This will simulate a CD-ROM being ejected from your computer. For those who had the chance to use external whatever what you call it, a CD-ROM on your laptop or computer, and then you'll be able to understand what I've just shared. Okay, so now let's go to some overview of Labview, which is, I put it here, 2021 assessment mini project. Is it here? No, no, lecturing. Hold on, Labview study guide. So this is actually just a simple overview of the manual. Actually, you can actually just open the you just launch the Labview and you can see it in the Labview itself. But I think the resource person has compile it in much more user-friendly manner for us to see what is the Labview, to understand, to overview what Labview is. Okay, so this is a Labview. This is how you see your Labview. This is the front, the block diagram where you design all your circuit, and this is the front panel where you interact with the operating parameters. Let's say it's running right now and you want to change the parameters, much similar to when you're doing in your lab. You want to change the parameter in your oscilloscope. You can just change it here. Okay, so that's the branch of it. So we are going to understand what does Labview stands for, how the virtual instrumentation, or what we call as VI, being used for measurement systems, the environment of the Labview, which consists of 3 VI, 3 palettes, how to use context help, and also the status bar. So what is Labview? Basically, Labview stands for Laboratory Virtual Instrument Engineering Workbench. Hold on, yeah. I don't want to hear you. Elias, I cakap apa tadi? Sorry, yeah. Okay, Labview is a software. Basically, it's just an application where you install on your computer, which uses graphical programming language. Now it is actually similar to C programming or Java programming, whatever, but it is much more user-friendly because it uses graphical programming. So that means if you want to program something, you just rearrange the block, rearrange the graph, or sorry, rearrange the connection for you to program the software. So it can be used for data acquisition, data analysis, presentation of the result that you have conducted, and also any kind of instrument control. Okay, sorry. So this is one of the example of the programming, the graphical programming that you can use in the sense of you can just get the spectral, for example, for spectral icon here, just drag it into the what do you call that, the block diagram. Yeah, the block diagram like this, for example, this one, and then you connect it to whatever connection that you want to do, and then it will produce the whatever that is being defined by the block diagram. For example, this one is shows the context help of the filter. What is the filter for us to understand what does filter do in this context of a graphical setting, the default setting of the filter being used here, which is for you to provide this. Hold on here. Where, as you can see, the signal coming in and the filtered signal, error in, no error, error out, where this is the output and this is the input, and this is where you define the error. And if you elaborate the detail help here, you'll see what is signal, what is error in, what is filtered signal, what is error out being defined by the library. This is basically when I say library, is actually what is being programmed in each of the boxes here. So yes, this is a program, but in the sense that all the parameters, all what is being done in the box is actually has already been defined by the source person, I think the Labview person, engineers, for us to just pick it up and fine tune it with the parameters that we want. Okay, I hope that is clear now, but we'll explore later. Okay, Labview program is called virtual instrument. We call it virtual because you can't touch it physically with your fingers, but you can touch it with your mouse. Let's say, for example, you want to turn on, or you want to vary the limit of the temperature. So you just turn this clockwise, and the knob will also turn from 75 to 80, or somewhere in between, for you to define a custom range while it's operating. So you can interact with all this button, but not with your physical fingers, but more towards your mouse or whatever interface that you have. If you have a mouse, trackpad, or maybe you have a, what do you call that? The pen, the pen that you can use to sketch. You can also use it if you have the library defined, you can also use it to interact with the panel shown here on your Labview. Okay, so this is typically how Labview is being implemented. Typically, this is your computer or your laptop. It will be connected to the DAQ system, which is the cards of the National Instrument or maybe other types of card that can be interfaced with the Labview. Typically, people will use National Instrument. And then from that DAQ, it will be connected to the sensor or the hardware, and then finally the object that you want to measure or being tested. So typically, this is how you would set up a Labview or VI approach. You need a computer, you need a DAQ or DAS, data acquisition system setup, which include DAQ and also its specific DAQ system. And then it should be connected to the sensor that you want to measure and also the object that you want to measure, the parameters that you want to get the parameters from. So typically this is how you would set up. Unfortunately, we in UiTM Terengganu don't have this kind of setup. It's going to cost us a lot, but I did propose, but we'll see how it goes with the higher management. Okay, so Labview Environment, basically it provides an easy to use graphical programming. The keyword here is graphical programming environment, which include all of the tools necessary for data acquisition, data analysis, and presentation of the results of the analysis that you have conducted. And it tries to make your life hassle-free as possible, but of course there is some limitation of a software. That means if you don't have the DAQ for that particular sensor, if you don't set it up, there's no chance that you can use your Labview to control it. You need to have some physical connection to the sensor or the operating parameter that you want to manipulate. If you don't have it, then chances are Labview can't help you there. But it also has extensive library that is being kept updated almost frequently, iterative frequently by the National Instrument. That's why Labview is quite costly. If I'm not mistaken, the last time I asked them how much is the price of the Labview itself, not the DAQ, not the card, not the sensor, not the machine, just the Labview where you install the software here. It took they quoted me around 30 or 20,000 per license. That means you have to install that one license specific to a computer, and that's it. 20,000 if I'm not mistaken. So it's quite expensive. And not only that, if you have the Labview, but you don't have all the architecture, the system, the physical architecture here, and here, there's no point of having a Labview. So you can't control anything, you can't get data from anything. So yeah, the whole system is actually pretty costly, but it helps in the sense that if you have a large operation or your business has a large production, for example, it smoothen everything out. In fact, it will save you the cost of operating in the long run. So in a way, it is a hassle-free, but again, the keyword here is as possible, meaning there are chances that you can't use Labview. So basically, you will have, or once you have a Labview, you'll be able to see the front panel, the block diagram, the icon, and connector pane for you to get all the to do your programming. You can do programming on your front panel, you can do programming on your block diagram, but you need the icon and connector pane for you to get the boxes that I've mentioned earlier. This one. So this is everything here is in icon and connector pane. So if you want to do this, use this on the front panel, you have to drag this onto the front panel. Sorry, the block diagram. Sorry, the block diagram. You drag it on the block diagram and create some line connection to whatever interface that you want to use, and from there you can control. Okay. Okay, so there are three palettes, which is the tools, the controls, and the function palette. What does a palette mean? If you know how to paint, if you understand how painting is being done, you'll have to have a base where you put on all the colors on the crevices on the what you call that as a palette. So similar to Labview, you'll have three types of palette, which is for tools, for controls, and for function. So tools is actually for your block diagram, if I'm not mistaken. Sorry, tools is for front panel. Function is for block diagram. Am I confusing control and tools? But we'll see after this. I'll show you in lab 1A after this. So if I'm not mistaken, tools and either tools or control you can see on your block diagram. But sorry, on the front panel. Tools you may have to customize it so that it shows on the block diagram or front panel. But we'll double check on this after this. Okay, and then context help for you to immediately search. If you know what you want to use, you can just skip the control and function of tools palette and just type in the help in help context, and it will give you the desired or whatever that you wanted, the programming, the library that you want to use. And status bar to show whether it is currently running or it is ready or it's not operating at all. So status bar is where you know whether your design, the circuit that you design, the program that you design is working or not. Okay, so again, front panel, block diagram, icon and connector pane is just similar to what I have just said earlier. So basically front panel is where the user put serve as the user interface where you interact with the button, with the graph, with the operating parameters, turning the knob or whatever to show the output simultaneously, and also for it to present the outcome of whatever that you've just interrupt in the process. So it is almost real time. There's some lagging, of course, but it is in 1 or 2 seconds as compared to if you go to the control panel on the plant itself. Of course, that will be much more faster due to its being real-time value sampling out from the sensor. Whereby front panel on the Labview, it will have some maybe milliseconds delay or lag compared to the actual front panel, because data has to be converted from analog to digital, and then digital transmit to the computer, and computer to translate that into comprehensible output. So yeah, of course there will be some milli or microsecond delay. Okay, and then block diagram is where you design your process control, the functionality of the VI. So it is actually an executable program. So if you recall C++, C programming in semester 1 or 2, if I'm not mistaken. So if you recall, once you say printf hello, so you have to compile and run. So it is exactly, when you run, is actually an executable program. So the one that you have created in the C program is also called executable program. That means once you click run, it will start to conduct the program that you have the design. And then you can view it similarly to a circuits, where each connection, the program will start based on the connection hierarchy, meaning if you start from, of course, everything will start from the power source. So it will start from, if let's say you design it start from the left, then it will start from the left. You start it from the top, it will start from the top. So it's performed similarly to circuits. Whatever that you design will be run accordingly. And then icon and connector pane is where they put the VI or the library for you to use it with another library or a sub VI, and it can execute a simple or complicated task with input and output terminal. Nothing much, but basically what icon and connector pane has is all the library of the icon, or sorry, not the icon, the program that you want to use. For example, you want to use current temperature, so you have to go to the icon of current. Typically it will be in not sure, is it here? No, this is more graphical analysis. You'll be using the control, if I'm not mistaken. They'll have some current temperature control. Then you can tap it in the block diagram and then use it with the front panel. Okay. Okay, then elaboration on the front panel, all the controls for input or interrupt that you want to control the process itself. Typically, it will involve knobs, push buttons, dials, and other input devices. Again, if you have any question, just ask. You can interrupt me anytime. Okay, control simulate instrument input devices and supply data to the block diagram. Indicators are typically being graphs, LEDs, and also other displays that has been defined by National Instrument in their Labview version that you are using. So if you're using like right now, 2014, so you have to double check what other displays are available for Labview 2014. I believe for 2020 would already have lots of all the Arduino displays and whatnot, but for 2014, I guess there aren't much, a bit limited, but you can always check if there's already some library being defined for you to use if let's say you want to use Labview for your final project. Okay. Okay, so this is an example of VI's front panel. This is the Boolean control on off. It's called Boolean because it's either 1 or 0, 0 or 1. And then front panel toolbar, whether you want to run the program or run the plant to get the output, and also any kind of variation of representation that you want to set. And then this is the legend. If you click on and then you set here front panel toolbar to run, you will see this green plot on the graph here, which indicate our running average or current temperature and whatnot. And then this is the legend if you want to what do you call that? Adjust the graph so that it is more comprehensible. And then this is the plot legend, which is degree F and time per second. If you want to change it to maybe millisecond, you can change it here, millisecond. And then waveform graph, nothing much. Okay, so basically this is a front control panel. You can imagine this. You can view this actually at the control panel on the plant itself. But rather than you going there, you can just view this on your computer. So it saves you the cost of running here, running there, just to get the data. Of course, it has some lag, but inadvertently is actually if your process isn't that critical, you can just get it from here, which actually is reflected on the actual data process itself. Okay, and then the block diagram. So a block diagram consists of the design of the circuit that you want to use, not circuit lah, the program. So this is where you program, okay, what kind of input is being used here? Sine frequency, sine wave, sine square wave, the square frequency. This is all the parameters of the input that you want to use, which being fed into signal simulation of a sine wave. And then this one is for simulation of a signal of a square wave. So the output of this wave will be inserted into a comparator, which can then be used to either plot it out directly, which shows the signal before it is being used or being inserted into spectral measurements to see whether spectral measurements parameters are correct or not. And then the power of spectrum can be used again to view it. That's why you put sort of like an oscilloscope here. And then the output could then be used to write Labview measurement file. Basically, this is more like data recording, data logging. So all the output from the spectral measurement, the power spectrum signals are being stored. I believe this will be in .txt. And let's say you want to stop, you just click this stop button here and everything will stop. Okay. So basically this is the program, the programming part. and this is the controlling part. Yeah, this is the controlling part. Front panel is for control. Block diagram is for program. So see, as you can see, it is graphical programming where you just define the block, what kind of signal that you want to use. Just double click here, change it whether sine or cosine or whatever, and then you can just program it by linking connecting the line to the whatever that you want to use. Let's say for this, sine frequency is being connected to sine wave, so that we can define the frequency of the sine wave, and this is for square wave. So sine wave plus square wave, or if I'm not mistaken, this is OR. If there's either signal, it will be inserted into power spectrum to show the power spectrum of the sine wave or the square wave. If you have any question, again, you can ask. Okay, and then, sorry, this is N. So N means AND gate lah. So N means it plus. So you'll see something like this for sine wave and then square wave. So you'll see both the signal because it is AND gate. So basically you multiply. Okay, and then this is an example of a block diagram where this is this while loop defined by the box, the gray box, and then this is the sampling time when the sample will be conducted. And if in this case it seems sample is being used to plot the temperature history. So, and then this is the sub VI, and this is how you run or stop the program. You can either stop it from here, or you can click on the front panel, this power button. If you flip it on, it will turn on. If you flip it down, it will turn off. Okay. Again, any questions? You guys okay?
Okay.
All right.
No question.
Okay, so your program is still installing, your Labview?
Yeah.
Okay.
It's installing.
Right. Okay. We'll continue because if possible, we want to proceed with the Labview, Lab 1A. So okay, then we look into icon and connector pane. So this is where you get your definition, or if you double click on this, you get the parameters you can set up on the block diagram, on the sub VI, on the while loop, or whatever icon that you put in the block diagram, you can just double click on it and to view or understand what is this icon is, or whether you want to manipulate or whatever, you can just double click on it. So that will bring out the correct connect icon and connector pane. Okay, we'll have tools, controls, and function palette, which we'll see later. So this is tools. Sorry, tools is more like a shortcut where you can use to do a simple edit, operating tool, positioning, labeling, wiring, and whatnot. But the controls and the function palette is the one that more towards what where you will be designing your program. So control palette is where you put all the knob, all the display output will be shown here, and the function palette is the one that you again get the program, the block programming, so that you can drag it out and put it into the block diagram for you to program the control panel. Okay, show context help is for you to use to understand what is, let's say for example, you got a sample of a block diagram from the internet, you want to understand, okay, what does this block do? So you can use show context help to help you understand what does this custom, I believe this is a custom block diagram. So it will start to help, it will help you understand what does this do, for example. Status toolbar, this is to show whether it's running, it's looping, it is currently aborting. If it's available, you can press on it and it will then go to being grayed, showing that it is currently stopping. And also you can also click here to pause the process if, let's say for example, you want to take a break or whatever. And this is for you to change any kind of font so that it's easier for you to read the output, for example. And all these are the variables that I'm not quite familiar, but I believe it's more on the rearrangement of the VI. Am I right? Nope, there's no mention here. But I haven't explored this myself, but you can just hover over it, it will show, which we'll do it later after this. Good. Okay, so this is the overview. Nothing much. It's just some brief explanation on what is Labview. So to open Labview, if you haven't put it on your desktop, you can just go to search on the what do you call that? Start program, Nature Instruments, and then click whatever Labview version that you have. But for me, I simply put it on my desktop for me to, because it'll be just until the end of semester, so it's much easier for me to just click on it. And then after the end of semester, maybe I could install it, uninstall it, and whatever, then I can just easily search for it. Okay, lab instruction. If you want to delve deeper into Labview, understanding it, you can go into Labview manuals, which I believe we would also have it once you finish up installing the Labview, which I'll show it to you later. But we would also have this in our start program once you've completed your installation. Okay, tutorial is nothing much. It's more on for you to understand what is Labview. Okay, begin designing. Okay, then I think, okay, discard. Okay, now we'll start. Okay, first we look into manual. So let's say, for example, you finish up installing your national Labview. So you just search for NKLMN, National Instrument. Like for Windows 10, it already has it on the outside, which is over here for education, and this is for Lego. So we'll just go for education. You can double click on it, and you will see this. So once you've seen this, I believe this is after you've restart your computer, then you can click Launch Labview, and you'll see this section pop up, which will be showing in about, yeah, right now. Okay, so before we start, I just want to take a break around 5 minutes before we continue with Lab 1A. Sorry, this one. So give me 5 minutes before we start with our pre-lab 1A. Thank you. Okay, 5 minutes up. So I guess we'll continue. Everyone's here?
Yes, sir.
Okay, thank you. Guess we'll start. Okay, hold on, give me a second. Okay, so we'll start with pre-lab 1A, which basically is just some introduction on how to use Labview hands-on. Since you're still installing, I believe you'll just have to watch this presentation, I guess, how to click and where to click. We'll be using the same Labview if you got it from me. So I think the deviation of the interface wouldn't be that huge, but I think Labview differentiate between each version isn't that huge. It's just that the location of the button may differ from one maybe 2020 Labview versus we are using 2014. So maybe the button location might be different, but in all it should be the same. More or less should be the same. Okay, so for this version we'll be using Labview 2014. So the objective of this lab is for, can I comment on this? Yep. Give me a second. Okay, so the objective of this lab is for us to understand the functionality of Labview and to help you, to guide you, to provide, to help you understand clearly on what is Labview. So what do we need is just a PC or a desktop if you have a laptop that is installed with Labview 2014 and onwards. But typically we'll be talking about 2014. So again, Labview stands for Laboratory Virtual Instrument Engineering Workbench. This is designed by National Instruments, so every product that you want to get support of or from should be addressed to National Instrument. It is basically used to control and design a project. You can also use it for simulation purposes before you do a hardware interface. You can use it for data acquisition and also automation and robotic projects. But however, before we start delve deeper into those kind of projects, we first looked into the introduction. Before we run, we need to walk first. Okay, this is like you see, this is Labview 2015. The interface is quite different compared to the one that we are using right now, which is Labview for Education 2014. But more or less, if the process of getting into our to start our work will more or less be similar. So nothing much here. It's just showing you the front page, which is in this, you'll have create project and open existing. The same thing here. We have create program and open existing. So nothing much. If you want to create project, which typically what you want to do at the start of the program, so you start create program. But if let's say you already created your program, you have drafted out and you want to improve on it, you just click the open existing. Or typically for a computer, you can just new VI or just open the program that you've previously created. Okay, so there are two ways to open it. So now we want to use create a new VI. So you can use Control N, which is new VI, or you can just create program. I haven't tested create program. No, create program is a little, which is actually VI, is also VI, and then create. So similar. So you'll have the block diagram. You'll be able to see the front panel. Front panel is where you'll see all the boxes, or what you call it, this checkered box, I guess. And the block diagram will be more or less like a white canvas. So if you want to arrange it, a simpler way is to press Control T. So see, it arrange itself so that it's much easier for us to see side by side what is the front panel, what is the code being programmed. So you can, it's much more easier for you to design your work like this if you view it like this. Okay, so Again, Control N if you want to use file. The step mentioned here, which is Control N or new VI. But like I've shown you just now, I create program and then VI blank. Then I create. So the same thing here is that you'll be seeing block diagram and front panel, and both windows and their functionalities are explained in the next parts. Okay, so first we look into the block diagram. So this is the block diagram. Again, you see here block diagram being shown and a white canvas or something like that. So this is where we design our block, our program. So if you double click, right click, you'll see select a VI or whatever VI that you have. Oh, sorry, this is for custom VI. So this is all the VI that we have for our block diagram. It's more of a back-end programming section. So back-end means that this is where the core of the programming is being done. And this is where you define the features that you want, or the simulation that you want, or maybe the code that you want to program. This is where you do it. You will be designing it, the block diagram. And then we look into the front panel, which is these boxes. So this is the GUI part, I guess it's called GUI part of the program, where you can interrupt, you can control the parameters, you can turn on and off on the knob, or whatever that you want to design is here. Sorry, whatever they want to control is being controlled here. So it's much more presentable. It's easy for you to see which knob will be not connected now, but which knob reacts to the effect of turning one knob or the other towards the process. It's much more easy for you to see this as compared for you to go to the plant itself to see the control panel, and then goes back to record your data. So this is much more convenient. You'll see the effect almost instantaneously to the process. Of course, you have to factor in data transmission and data conversion lag time. But all in all, I believe if your process doesn't require that too accurate of a reading, I guess this would be sufficient. So both of these windows are equally important and work simultaneously, meaning if you change a parameter here, it will also be reflected. I guess we'll be showing it like this. Yeah. If you operate, or if you change a parameter here, the same changes would be applied to the block diagram, which maybe lab 2 will be lab 1B, I guess, will be seeing the effect of it. So if you change anything in the front panel, its counterpart in the block diagram will also change. So first, we look how to align these windows in Labview. So align is what I've just shown you, which is Control T, and then you will see similarly like the one that I've just shown you. It will be, if you have a large monitor, it will put it side by side. It's much more easier for you to see lah. But if you have a small laptop display, chances are you'll need to minimize and maximize the one that you want to view so that you can view it clearly. But if you have a huge monitor, 24 inch onwards, it's much more easier for you to view it like this. So any changes you made here, you'll immediately notice that you need to put it also here. So you can also, let's say for example, this is minimize, front panel is minimized. You can also press Ctrl E to bring it back. Not sure block diagram can be used. Yeah, similarly to block diagram, if your block diagram, let's say for example, you have a small laptop monitor, so you can only view one window at a time, then Ctrl E to bring up both. Okay, and then description of a block. Okay, what are you going to discuss here? What is your discussion that you need to put in your lab report? First is just how to create a program, a new VI. Second one is what is the block diagram? This is where you design. The front panel, what is being done here? This is where you control. And then Windows alignment is how to help you visualize the the what you call that, the block diagram and front panel when you start to design it. So this is more like a shortcut manipulation. Okay, then we look into description of a block diagram window. So block diagram window is created using logic by using different blocks. These different blocks is actually a library, is what we call a library that has been pre-programmed by default by either the national instrument engineer or the communities, and being improved on by the engineers. And Is Labview basically supports FPGA or field programmable get array language. I'm not quite familiar with FPGA because I haven't myself play around with FPGA programming, but I would assume it's C based. Everything is actually C or C++ lah. Any kind of programming is just C or C++. But the format or the context, sorry, the what do you call that? The not convention, but the syntax. The syntax may be quite different from the original C or C++, but I would assume is what the programming being used to define the library of the boxes here. So we have to select different blocks that you want to use according to the requirement, and they are known as FPGA blocks. So this is called FPGA blocks. I called it library, but it is the correct term will be FPGA blocks. And if you want to view this, you just have to right click. Now this is a typo. It's not front panel. It is actually because you want to use this to code. So you have to right click on the block diagram. This is not front panel. This is block diagram. So pardon my nice writings using mouse. So you just right click on the block diagram and you'll see all the functions palette. This is the function palette. As you can see, if you expand this a lot more, you'll be able to see similar to whatever that's being shown in the example there. So now you want us to click on programming. Let's say, for example, programming here. There you'll see programming, which is similar to structures, array, cluster, similar to the example being shown here. So just right click. You don't have to, you can actually use this view and then function palette. This is much more, I would say, dumb proof way lah. But if you start to familiarize yourself with Labview, you'll be able to appreciate the right click function of the block diagram. If you right click, you will see functions. If you right click on the block diagram on the canvas. Okay, and then this is how you basically this is how you bring out the function palette in the block diagram. So this is your findings, your discussion on this part. And then part G, numeric toolbox in Labview. This is how you view. Okay, let me maximize this. Okay, so you want to, let's say you want to do some addition or subtraction or maybe a square root. You can do it simply by clicking right click, and then go to programming, and then goes to numeric. Which is numeric? This one here. So if you click on it, or maybe just hover over it, just hover, you'll be able to see whatever function that it has, the sub VI that it has that you can use. So let's say you want to use add. You just hold left click on add and then drag it onto the block diagram. So there. So let's say if you want to add subtract after this, so you click on again function, right click, and then programming. You don't even have to click. It's apparently it's just open it while you hover over it. So goes to numeric, which is, where's the numeric? This one. Hover over it. Then let's say you want to use subtract. Hold the left click and then bring it to the block diagram. So again, if it's too small, what you can do is you can press Control and then Shift, not Shift, alternate. I forgot how to control the zoom. Zoom in, zoom in. Oh, it doesn't have a control to zoom. If I'm not mistaken, when I was using Labview back in 2010, there should be a zoom in function, or am I missing it somewhere? Anyhow, let me explore it later, get back to you later, but apparently we can't zoom in the icon right now, maybe because numeric function of this, or maybe my screen is, because I'm using 1440p pixel, so there's a big chances that it is being Windows optimizing the display, so that's why it's look too small. But I'll explore a bit later how to zoom in or zoom out the design. Okay, but basically what part G is showing is actually how you can get the numeric sub VI into the block diagram if you want to use it. You want to conduct additional or subtraction, you can just use this. Okay. Okay, next we go to part H, which is the graphic tool. You can use this again by clicking on block diagram and then right click, expand, and then go to, let's say you want to make an alarm sound. For example, if a certain parameters exceeded the operating temperature or operating parameters, goes into programming, and then goes into graphics and sounds. You know, this is a bit annoying, but yeah, what to do. Okay. As you can see inside the programming, graphic and sound. Okay, so as you can see, even in graphics and sound, there are actually other, almost another layer of sub VI where you can, let's say for example you want to use sound, so you can just either output the sound from your file. Let's say for example, can we play this? No, there's no sound here. But again, you just double click on it, and then once you reach a certain parameter which you can define, if you double click on it, this is the parameters being defined for this icon. But this is after this lah. We will explore after in lab 2B, if I'm not mistaken, how to set up the parameters. Okay, so that's how you open the graphic in sounds, and then we can do the comparator. We can use comparator, again the same thing, right click on the block diagram canvas, and then goes to programming, and you want to do comparison, which is this one. If you hover over it, you'll be able to see the example being shown. So not equal to or less than, then you can just use it. For example, you want to use greater than. That's, you don't even have to hold actually. You just single left click, and then it will drag the icon or the program, the sub VI, into the block diagram. Once you double click on it again on the left click, there. That's an example. So again, function, expand, programming. You want to use comparison. Okay, let's say you want to use not a number. So single left click, another single left click on the canvas. So there you go. As you can see, this is a much easier way for you to code a program rather than you type. If you recall C programming, if you want to do addition x plus y, you have to type x equals to x plus y and then semicolon, and then you'll be able, and then you have to declare the value of the x and the value of the y, and then you code the program onto the C programming, whereby in graphical interface, you'll just have to click, click, click comparison, and then let's say you want to set less than, so click, single click, and then paste. Just a single click, it will automatically paste on the block diagram, as you see here. Again, this is much more easier. Although I have to say, based on my experience, anything that is easy will be hard somewhere else. So for example, this is easy here, but at the cost of having the reduction in data sampling time availability lah. So if let's say you have what you call that, a process that operates changes in millisecond, or microsecond, then chances are you will miss a lot of dynamic properties of that process due to you being using Labview. But I don't think it's going to be that hard. I mean, it's going to be that fast. In any kind of industrial processes, chances are Labview will be more than sufficient for you to capture the dynamics. Okay, moving on. Loops in Labview. Now, I have been using for loop back then, but if I'm not mistaken, my controller wasn't really that great. So I might need to explore for my recent research project. Maybe Labview could help, but we'll see after this. Okay, so part J, loops in Labview. You can do loops like typical programming, like a for, while, if, else, whatever else you can use the functions, programming, and structures. So if you want to access that, again, right click, expand programming, just hover over it, and then goes to structures, which is this one, structures. I'm hovering over structures. I didn't click anything. Okay, now I left click structures. What does it want? Nothing much. It's just showing you the structures, how to access the structures, the looping. So if you want to use while, for, and whatever, isn't there any? I must be daydreaming something. Anyway, that is how you open structure palette. And then how you want, if let's say you want to set the sampling time for the process, again, just go to programming. You don't have to click anything, and then just go to timing, which is this one. Hover over it. It will be nervous and start to show to you the parameters or the sub-library being defined in its program. So let's say, for example, you want to use tick count. Just left click and then put it on the block diagram. And then after that, you'll be able to control it by double clicking on it, if I'm not mistaken. Nope. Properties. No. I guess there's a way where we can define the millisecond, but I need to brush up on this because it's been a long time again. Okay, driver support in Labview. This is basically if you have extra function that you want to use that is not currently being defined in existing installation Labview that you have. For example, what we have right now is only tools. Hold on. Is it tools? I'm not sure where is the thing is being defined, but if you go to function palette or tool or control palette, you'll be able to see the what do you call that? The driver that is being already installed, the library that already been installed together with installation process. So programming measurement is where you get all the block VIs. So yeah, if you have additional palette that you want to, driver that you want to use, you need to install it in the function palette or maybe a control palette, which I don't think it shows or guide us how to install, because I tried installing this Arduino palette in the 2014 Arduino driver in the 2014 version, but I must be doing something wrong just now because I haven't been able, because it stated it requires support package 2020. So I'm not sure whether the one that I'm downloading isn't actually being able to be used with 2014, but I'll check on it later and then guide you how to install a custom library on the next class, I guess. Okay, so we are almost near the end. Okay, so next we look into front panel. This is just the block diagram only, so we can minimize this and start to look into front panel. Hold on, give me a second. Sorry, did I mute my mic earlier?
Clear, sir.
Clear. All right. But the one that I mentioned, part M, part L, you heard it right? Some feedback, please. I'm afraid. Have I muted myself just now?
No.
Okay. All right. Okay. Next, we look into the front panel. So the front panel, how we operate is exactly the same as block diagram, except for this time around, we'll be seeing control. So if you right click on the front panel, you'll be able to see control palette. See control. I think you can pin on it. Yeah, if you pin it, it will not be leaving. So for example, okay, if you want to use numeric, and let's say you want to use vertical gradient. So you see, because I've clicked on the pin, so this palette is not moving or it's not hidden compared to the example I've shown you earlier, where if I just drag this icon, put it out, and then this item will be hidden. But if I pin on it, it will not move, so it will just be always be there, so you don't have to right click every single time you want to use it. But if let's say you don't like it like this, you can unpin it. If I'm not mistaken, how do you unpin it? View this palette as icon text. Nope. How do I unpin it? Oh, just okay. Just click the. So if you don't click it, if you don't pin, press the pin button. Let's say you want to use Boolean. There, it will be hidden once you have dragged the item that you want. If you prefer that way, then make it that way. But if like me, at the first time when I first start to design, I'll like to see the controls much more often, so that easier for me to click. So I'll just press this pin button so that it's being pinned on the front panel, and I can just carry willy-nilly whatever I want to use, and see it will not be hidden. So it's much more easier during the first time that you want to set up. But once you have set everything up and your circuit is quite complex, it's much better for you to just hide it. So it'll be much more easier for you to operate like this to design. So every time you want to use it, right click. Okay, so that is how you open the control palette. And then let's say, for example, you want to use decoration. So we right click and then goes into decorations under modern, which is this one. And then where is the decoration? Okay, this one. So I hover over it. Let's say, for example, you want to make it more pleasing to the eye, and you want to use raise right. I'm not sure what this is, but never mind. So if we double click, what does it do actually? Raise right. It's not showing. And or maybe you can just search context help, raise right. Where can I use this? It's not showing the. I'm not quite familiar with the context help, because normally when I want to use it, I'll just Google it. But for now, I guess I need to explore and explain on you later. But basically, this is how you do your decorations. If you want to use decorations, you can just right click and then goes into the palette that you want, which is controlled at this, and then go to VI modern, and you can just hover over it and can look into it. I'm not sure what does this to decoration, or it's more like indication of how where it goes, I guess, because again, this is just decorations, not a function. Again, this is for better external look to indicate where the process is flowing. And let's say, for example, okay, Boolean, this one, you can just hover over Boolean. If you want to use on-off button switch, let's say you want to use toggle, there, toggle. If you want to, if you double click on it, it will go to the block diagram associated with it. So the reason why I double click on this icon and it's not showing anything is because this is just for decoration. It does not have any meaning, and it is just being used to make it more easier to look at for the eyes. So let's say this is indicative that the fluid is flowing to the right, so you can just use this. Okay, so Boolean, stop to terminate the program. So let's say you want to use stop. So let's go for Boolean and then stop. So if you double click on stop, no, when it's running, it will be connected, but if you double click on it, is it being connected to anything? No, I guess. Okay, I need to explore on this, change to control, change to terminal, what is being done here. But basically, if you want to use any kind of button here, you can just Boolean button, you can just right click, go to Boolean, and then go to which button that you want to use. Okay, and then graphical visual display. If you want to view the graph or you want to plot the charts, you can do it in real time using controls, modern, and graph. So control, modern, and then goes to graph, which is this one. Sorry, you just need to hover over it. So let's say you want to plot feather plot. Just double click on it. And no, single click, left click, and then put it here. So if let's say there's a data that you want to show, you need to define the input and output and then put it here. It will then plot it almost in virtual time, in real time, virtually in real time, but of course there's some lagging you have to account for. So there's also 3D graph, which is very good for us to understand, which is this one. For me, I haven't had the chance that much to explore the 3D graph, so I'm not being able to explain you why we need 3D graph and how we defined it. But I guess for diploma level, I don't think you'll be using 3D graph. But if you want, again, there's this context help here. If you type in 3D graph, you'll be able to see the definition of the PI. So that's how you use context help to help you understand what is the and how it is being connected and how it is you can use it. Okay. And again, if you don't want to use this, you can always go to National Instrument discussion board. Typically, people will the engineers will be very helpful almost immediately. If I'm not mistaken, back in 2014, back when I started to meddle with Labview, I want to create my own controller. I'm stuck for around one whole week, I guess, or 2 weeks, because I couldn't understand what does this block do. So I ended up emailing or posting a question to the engineer, to the board, immediately around 1 or 2 hours after that almost, because of course you have to consider the time difference because they are based in US or India, I'm not sure where. So immediately after that, I get an note on my email saying that my question has been answered. And when I go into it, yeah, they are very helpful in assisting you to understand Labview process. So don't hesitate. If you try to use Labview and you don't understand anything or something, you can just ask. If you have gone through the context help and you can't find your answer, you can always go to the forum to help you get the answer that you wanted. Okay. Again, this is for you how to use the search button if you want to use or you want to understand a simple block diagram, for example, or maybe you just want to find a block diagram. So let's say you want to use 3D. So you can just go to this 3D palette and you should be able, 3D curve. So if you click on this, I don't know why it's so slow. Maybe because I don't know. Labview is quite slow. I'm not sure what happened. Hold on. But now this is where you could reduce the time process for you to get your block VI. Supposedly, I'm not sure why it's not working right now. But you can also use quick search, which is simply by pressing Control Spacebar, and you want to use, let's say, for example, a 3D line graph, configure. Let's say you have set it up and you click OK, then you can just post it on the front panel if you want to use it directly like that. Okay, so that is roughly what Lab 1A is about. Basically, it's how to use the Labview in general, how to plot all the data, all the knobs, how to insert it into the front panel or the block diagram, and then how you can quickly search for the VI that you want to use without always double clicking or right clicking. It seems my Labview is having some problem because even right clicking is a bit. Oh yeah, okay, maybe because this 3D graph function is a bit heavy. Let's see, 3D. Okay, but if let's say for example you want to do filtering, I mean you can actually just go into specific each of the library here, palette here, to see what kind of PI did they offer. But if let's say you already know what you want to use, let's say low pass filtering, you can just Control Spacebar and then type here filtering. Okay, let's say for example filter. Why doesn't it have it here? Configure. No, this brings out the front panel. This is a custom. This is a custom VI. Be over here. I'm not sure. My Labview seems very sluggish. Maybe because the 3D graph. Let me try delete it. Can I remove this? Delete. Can't seem to. Okay. No. Yeah, delete. Just press delete. Sorry. So let's say you want to use filtering VI. So you can just type over there and then there's a filter. So see, it's quite fast. Where does it go? But why is it? My Labview seems very sluggish now. I'm not sure why. Maybe because I've wrongly clicked the 3D view just now, so it affected the reading of my Labview operation. But never mind. But that is how you quickly gain access if you already know what you want to use. So let's say for example filtering, just click search, and then let's say you want to use filters, and just search which one that you want to use. Sluggish. I guess it's processing or something. So that is pre-lab 1A. Your finding, what you need to discuss is what you understand from each of the part is being shown here. This is actually very simple. You don't need my guide actually. You just need to test it on your own and derive your understanding from it. Okay, any questions so far on your lab?
No question.
Okay, I guess since you got no questions, then let me ask you, have your installation been completed? Is there any problem with the installation?
I already done with installation, but not restart yet.
Okay, because you can't restart because we are having our session right now. But I advise you to restart your program, your computer, because it will. I think it got to do with the loading of the library. Because if not, like this, I've already restarted, but it seems a bit sluggish, I guess, because the 3D graph takes a lot of memory, I guess. So yeah, I don't think it's performing well. But for this class, I have achieved my objective, which is to discuss on the pre-lab 1A for us to for me to introduce Labview on how to use it, and hopefully you'll be able to understand a little bit more on Labview by you doing it yourself after this class, using your own version of your Labview. Okay, so that's all for our lab. You'll have to test your, what you call that, the Labview on your own after this. But again, the channel is always open. You can always ask me, even after class. You can always ask me in the WhatsApp group, that we have. Just if possible, try to snap the screen. Don't just put into words and expect me to understand which is which. If possible, if you have any question, try to snap the picture for me to understand what issues that you have. Let's say, for example, you have an issue like this, then try to snap it and share it. If possible, ask in the WhatsApp group, not personally, because at the very least, if someone else is having the same case as yourself, I don't have to explain 2 or 3 times after that. So everyone can learn. Besides, this is just installation issues. So for those who may have it, I guess everyone will also be having it. So it's much better if we can go through it together. Okay, so in regards to the lab report, I will be giving you the link for your submission in the Google Classroom for you to submit there. Okay, the format, the same as any kind. I mean, I'm not concerned on the format at all. There's no formatting that you need to focus on. You can do it similarly to any lab format that you have done yesteryear, last semester, whatever. You can just reuse it, but make sure all the names, all the details, your matrix number, your class number, sorry, and the topics, which is Introduction to Labview, Pre-Lab 1A, is there on the information on the front page. And then all the details, you just discuss on part A, what you have learned, part B, what you have learned, part C, whatever, and so on and so forth. And then at the end of it, you need to have a discussion and conclusion and references, if any, which is you can cite this manual and also National Instrument, what you call that, the website, and just put it in the reference. So whether you want to use Arial 10 or 12 or whatever, it's up to you. But that, my concern is on the information that you put in your lab report. It should be concise. Name, matrix number, class, and also the discussion, conclusion, and your finding accordingly with the parts and also the references. Okay, so that is what I expected from your lab report. And after that, if I'm not mistaken, okay, normally what I would do is for you to submit a week post lab. Meaning, if we are doing this lab in Sunday, like this right now, you'll be submitting your lab report on the next week Sunday, and so on and so forth. So let's say after this we'll be doing pre-lab 1B in Tuesday. So your lab report will need to be submitted on the next week Tuesday. So I'll give you 7 whole days for you to do a simple report. Actually, it's not, you don't have to concern. If you spend 1 or 2 hours, I guess you can submit it almost immediately. This is just a simple exercise. So if possible, try to do it quickly as possible so that you can focus on other things. So I guess that is all. If you have any question before we end our session, please don't be afraid to ask. Please ask. Do you have anything?
Sir,
Yeah.
you will be putting the video right away after this, right?
Yep. Since this is lab, I'll be, I guess right after this class, I'll be processing all the video editing and whatnot. If you need it, then I'll be posting it in the ODL link lah, in your ODL
Okay,
link.
sir.
All right. Other than that, any question other than that? Last week's class, I've already put it in. I'm sorry it's a bit late because I'm quite sluggish, yeah, because I've just completed my second vaccine. So apparently the effect on me is that I become tired, sluggish, and also sleepy. So yeah, that's why last week I was quite. A week after that, or before that, was I'm quite busy with other tasks. So yeah, but I've already put it in here, so you can already see it on your ODL link summary. And for this class, for this lab, I'll be putting it right after this class. Okay, so I assume there's no other question. Okay, if there are none, then I guess we can postpone our class with Tasbih Kifarah and Surah Wal-As. Okay, thank you for your time. Have a good day, everyone. Thank you, and hope to see you next class.